So this is basically the coding for the mode shapes. Some of these matrices initially won't look familiar per se, really just to set up a database to pull from and compare to. There's really no statements or loops yet. You'll see here that this continues on. So we get to these primes here. This is a list of primes all the way to approximately 8,000. And then there's this BB vector right here that is a shorter vector list. Then we start getting into the statements. See here that we even start to create vectors within those ones that we made earlier. And this is the if statement list and constraint for A. Here we begin loops and for our results and so forth. Here's more loops for the A. We get into the actual plotting portion of it. You can see right here, this is showing that the slope is decreasing from 4 to 3. This is just more handles and random handles. Here we're going to have a W error. This is to show that a space is needed. Here the error message because of so. But if you go further down, notice there are some other matrices that are added. And then we get into a slope negative to positive and then a broader Y spectrum. You'll see our W vectors here correcting the W error on the prompt below. This really plots integral, but you get all the way down here to quid quo, and then you see our menu bar over here has been extended quite a lot. We get into a point where we really need handles, so we got this JavaScript gets into R script. You can see here that we have more pulse mechanisms for our mode shapes. And then we get down here and we have an empty space, a G space for a Z space from 7 to 2. It's really just to plot against other matrices. Now we get into the M space, since we're past the W space. You'll see here that we have a threading, basically diamond shaped for parallelogram of all the different nodes, all constrained within a very finite area. This here, we're coming up on a V error. Here you can see the space has been constrained down partially. Here we'll have one slice of that to show one of the four corners. And the edging portion of it, right here we have basically another plot. How to discretize it into more linear shapes. Here we're getting into the VV error that I was telling you about. She shows up on the prompt down here. For this error, we come up here to condive. This one's a little tricky. You gotta pull this one first, this one next. Here you can see our VV right here. that we're missing. And then the loop for that sequence. You can see kind of an impulse and a plateau for our Hilbert space. So we're really going to just run through all this code. What we're really looking for, right, is going to be this right here. Gets into holographic portionings, but this will constrain it to a zero node and how it diverges in each direction. So we get further down and we can start plotting other methods. You can see that it's expanded that node into a larger database, more of a macro database. And then we're pretty much finished with this. Con dive. So here we have more missing nodes. This will kind of look like a bullet, but this sets up for our holographic space. So now we get back into the MP. We had the error for the VV here, but we need these L spaces. And you can see over here that now our L spaces have come in. And then we continue to this plot, which is familiar. This should be the 4-space plot that we spoke of earlier, cake. The corresponding loop for stepping it up, there's our discretization node. And we get all the way down to where we plot GIF. GIF is our main node that we're going to pull in. GIF is adding in our mode shapes that we plot in that we can get into later on, but I'll show down here in the prompt that the plot of GI is then the holographic space we were speaking of, and how it can be zeroed out by the Hilbert space and contrasted with different vectors that will change the colorization of this for RGB in between. Now we're into where we're getting our factors of safety. So again, we plot that GI. You see that it's right here in the factor of safety space. We also then got to get into where we plot our mode shapes. Down here in the prompt, you can see most matrices it'll plot. We're going to go ahead and use QCO, which is from Fusion 360 data. We'll plot that. You can see in the prompt that it took it. So we get into more statements explaining more plots. This one right here is really the R vector for price. This is just random numbers. Honestly, if you plot it with a different matrix that represents this kind of cubic translation, it just helps interpolate it. So this makes it a little bit easier to approach that system. And then we get down into a little bit more C spaces that pull in other functions. You can see over here, you know, our workspace that it just keeps expanding when we pull these functions in or variables in. We're finally getting down to the main portion of the G space, trying to describe where mass begins. Dingus is kind of a playful function in which we kind of pull in more variables and then try to pull in an empty space, or sorry, mode space for the factor of safety. We had 8 mode shapes, but that's going to be not enough. It doesn't have 9 variables to represent the 3x3 matrix, so you can put in a 1 or 0 in the last variable, and that gives you x1, x2, x3, and that's what these kind of represent. Is three space vector that you can receive. This one here is more of our play space. This is what's coming up. So it's really going to be into our B vectors from A to B. As you saw from the beginning, we began with A, now we're leaving off in B. We're trying to define C as we do this. So we can, BIF should be a null matrix that really helps us out with some zero spaces in our Hilbert space that need translation. So if we plot BIF, you'll see a zeroed out space right here that represents our null space that's just kind of grounding us. So that's where we're leaving off. That's basically just as updates come along,